Today, I'm going to show you how to get started with cuTile Python. To get started, we'll need a couple of things. First, we're going to need a Blackwell GPU. That means a GPU with compute capability 10 or compute capability 12. We're going to need the NVIDIA driver version R580 or later installed. We're going to need the CUDA toolkit version 13.1 or later installed. We'll also need the bin path of the CUDA toolkit in our system search path. More on that in a moment. And finally, you're going to need Python version 3.10 or later installed. So now we're looking at a terminal on my development workstation. I'm going to type NVIDIA SMI, and we'll see that we are on driver version 580. And the GPU we'll be using today is a Blackwell RTX 5060. Now, I mentioned that you need the CUDA toolkit installed and in your system path. The reason you need that is that cuTile Python is going to make use of a program from that called TileIRAS. This is the optimizing assembler for the cuTile platform. So if we just type TileIRAS and it finds the application, we see the help here, so it found the application, we're good to go. So now let's install cuTile Python. All we need to do is pip install cuda-tile. That finds it, we've got cuTile Python. That's all there is. Now let's look at some code. So all the code I'm going to show is on the GitHub repository for cuTile Python. I'll put the address on the screen. We'll also put a link in the description of the video down below. Vector addition is kind of the hello world of GPU programming. So we're going to start with a vector add using cuTile Python. So here's our code. We start with some imports. The most important import I want to talk about is this one, import cuda.tile, that's cuTile Python, as CT. That just means we're going to call it CT in this. The next line says @ct.kernel. That indicates that the next function we define is going to be a cuTile kernel. So our vector addition is going to be code that's going to run on the GPU. It's going to take 3 arrays, A, B, and C. These arrays need to already be on the GPU. How you get them there is kind of up to you. This example shows it in cuPy. Some of the other samples in the repository show it using Torch. You can use either one. Now, we're going to launch this kernel as a grid of blocks. Just like in conventional CUDA, where we would launch a grid of thread blocks, we're going to launch a grid of tile blocks. So the first thing we're going to do is figure out which block we are, which is going to determine what work we're responsible for. Knowing that, we can then load data from memory, from these input these input arrays, into tiles. Tiles are data, remember. So we have an A tile and a B tile. These are one-dimensional tiles, they're vectors. And then we're going to do something with the data we've loaded. That is, we're going to add them together. That's going to create a new tile called result that stores the result of adding A to B. Then with that result tile, what we're going to do is we're going to store it. We're going to store it out to the array C. That's our vector add kernel in cuTile. If we scroll down, I'll show you the important bits of the host code. Is we create the arrays on the GPU using CP is cuPy. We instantiate A and B as random uniformly distributed vectors, and then C is just zeros of the same shape. We launch our kernel, and then at the end we copy all of the arrays back to the host so that we can add the numbers together on the host and verify that the GPU answer and the CPU answer are identical. And if they are, we will get this happy print that says the vector add example passed. So if we want to run this, so I'm already in the folder for the repository for cuTile Python, we just type Python. And then this is in the samples folder under quick start, and it's called vector add quickstart.py. If we run it, we get our happy print. So that means it worked. There you go. That's your first kernel in cuTile Python.